Hi everyone. The paper that I will present today is entitled How Are You? Estimation of Anxiety, Sleep Quality, and Mood using Computational Voice Analysis. And this is Samuel Kim from Canary Speech. This picture shows usual social gathering we used to have before COVID-19. Well, I hope that, we can have this kind of gathering sooner than later. But anyways, when we greet, we usually ask how are you a lot of times. It is beyond just greeting. We ask the question because knowing each other's emotional and physical status is very important in human-to-human communication. And there is a growing body of interest for a computer to know humans' emotional status as a human-to-machine interaction becomes new norm in our daily lives. So the computers and machines can serve better their users. In this study, we also want to ask the same question, basically how are you, to estimate impactors of cognitive function, also known as ICF, and to see if a computer can actually do it. In particular, we only use speech. Why only speech? Because speech is an unintrusive way of doing it, and is fast, innate, synchronous, and very dense in meaning. Indeed, speech has been studied as a biomarker to estimate various healthy conditions, such as depression, schizophrenia, as well as the Parkinson's disease and ALS. We also use speech in this study, assuming that a subject's condition is somehow embedded in the voice by modulating articulatory organs. We study three aspects of impactors of cognitive function. They are anxiety, sleep quality, and mood. We use the clinically validated questionnaires to collect measurements of the subject's emotional and physical status. For example, for anxiety, we use a STAY and GET7. And for sleep quality, we use PSQI. And for mood, we use PANAS. These are all validated questionnaires. For all these instruments, you don't want to get a high score, as the higher score represents the worst status you are in. For example, the higher anxiety score, the more anxious you are. To do this, we developed a mobile app that collects voice samples from the subjects as well as the validated questionnaire in digital forms. So we recruited 219 subjects and we asked them to perform 5 sessions. And each session, they record 7 different recordings. And finally, there are 203 subjects who are completed at least 3 sessions. We analyzed the demographic information of the subjects, including gender, age group, as well as education level and ethnicity group. We conducted significant tests to see if there is any potential impact of the demographic characteristic, but we cannot find any significant influence on the primary research objects. So the data collection is a valid process. And this figure shows distribution of the collected instrument score distribution for STAY and GET for anxiety, and PSQI for sleep quality, and PANAS for the mood. We also collected speech samples. As I mentioned earlier, we collected 7 recordings per session, and there are 4 short sentence readings. The length is on average 5 seconds. And there are 2 paragraph readings. It's longer than the shorter sentences, so the length is around 50 seconds. And there is one spontaneous speech which does not have a predefined text to read, so the length is a little over 1 minute. So after the data collection, we have around 1,000 sessions, and each session has 7 different recordings and 4 different instruments to represent the user's condition. Now, it is a classical problem, classical machine learning problem that we are dealing with now. So there are 7 different samples and 4 different instruments scores that we need to build. So the question now is, how do we extract the features from the samples, and how do we model those scores with the given samples? So the first part is feature extraction from the single audio file. The features are in 2 categories. One is how it was said, and the other one is what was said. To extract features regarding how it was said, we apply various signal processing methods to investigate spectral characteristics and its prosody. And for one audio file, we compute the statistics of the spectral characteristics and prosody to come up with a set of acoustic features. On the other hand, to extract the features for what was said, we use ASR, which is an automatic speech recognizer, to transform speech signal to text, and then we analyze it to extract a set of language features. So now we have a set of acoustic features and a set of language features to represent one audio file. And then we select the features that are salient to the target label. The feature selection is done by selecting top-end correlated features with the target label. And since we have 7 different speech signals, as we discussed earlier, we need to devise some way to come up with the one feature from 7 different audio files in a session. So we concatenated those features, those selected features from 7 different recordings, and concatenated to make a super vector that represent a session. With the extracted features, we finally have to build a model that represent those instruments of the scores of scores. We use a fully connected deep neural network with the 4 hidden layers with the 256 neuron units for each layer. We build 4 separate models for each target label. Anxiety. For anxiety, we have a stay and get, and sleep quality, we have a PSQI, and the mood, we have a PANAS. So there are 4 separate models. We perform 5-fold cross-validation, and the performance was measured in terms of a concordance correlation coefficient. So the results. These figures show the scatter plots of the self-labeled scores, which are on the x-axis, and the predicted score, which are on the y-axis. The results show that there are significant correlation between original self-labeled score and the predicted scores. The results show that this is significantly better than the conventional way. Likewise, for sleep quality, mood, same applies. In particular, we can achieve 0.5 correlation coefficients for PSQI, which represent the sleep quality. So the conclusion. In this study, we show that the speech can be a non-intrusive measurement of the impactors of cognitive function, namely anxiety, sleep quality, and mood. Our future work will apply more advanced machine learning techniques with more data collected from a larger population. Thank you for listening, and these are the collaborators that I work with on this project. If you have comments or questions or any other matter, please contact me personally so that we can communicate each other. Thank you so much, and enjoy your conference.